About a year ago, we started building a new project, which is now in public beta. It's called Cloudera Search, and Morphlines is really a spin-off from that project. You know, it came out of Cloudera Search, something that was directly useful for us, but we're now also making it available to a broader audience because it's more applicable, beyond the boundaries of just search. And so I'm going to talk a lot about that and how and use search as a use case, as a motivating use case to illustrate some of the example applications. So we'll talk about big data and ETL and search and how it all fits together, and then dive into what the fundamental elements of the architecture of Morphlines are, and talk about some of the aspects in more detail and take a dive, and then see how the technology can be applied to example use cases. And I'll oftentimes, use Cloudera Search because that's what I'm more familiar with. But part of the reason why I'm here is because I want to learn and know what you guys would like to do with it, and where else we could take this technology beyond search. So here's a motivating example ETL use case that is centered around search. We have a bunch of information coming in through that's generated by some online systems, like websites, trading or e-commerce sites, what have you. And it comes in through basically like a large-scale ingestion bus called Flume, and is being indexed into a system called Solar Cloud, Apache Solar Cloud. And there's essentially raw data streaming into the system. The way it's being captured, say like by an e-commerce site, which is not necessarily in the right shape for consumption by a search server. So what happens in the process then is that this data needs to be massaged into a data model that actually represents this, the search application, or what the clients want to do with a search application. And so we have an ETL flow that transforms the data from its raw form, from potentially its very unclean form, into something that is directly applicable to a search server. We also have, at least in our context, large OLTP databases like HBase that are feeding into search servers. And again, these databases contain, all sorts of different kinds of information with all sorts of different kinds of schemas. And they were built for applications that don't necessarily have search in mind, but you also want to make that information searchable. So again, there's a step there to transform that data to actually make it useful for a search application. And that ETL, that extract, transform, and load step, is what we're going to talk about some more in detail. Further on, the Flume ETL flow is essentially a near real-time indexing flow where data comes in online from some sources and needs to be indexed and be available right away. In HBase, similar. Oftentimes people want, whenever there are updates, inserts, updates, and deletes in HBase, you want to have that information being reflected right away or close to right away into a search index. But then there are also, more larger applications where you run giant batch jobs to generate search indexes from existing information in HDFS, in the Hadoop storage system, potentially index your entire storage system, say like, 10 petabytes of data or something like this, using MapReduce jobs. And again, the information is stored in files in whatever, gazillion of different file formats, gazillion of different, ways, not necessarily, ready for consumption by a search index. And typically it's raw data, and so it needs to be transformed, and that's the function of ETL in that flow. What you see is that there's multiple paths, there's multiple cases where we need an ETL component, and there's not just a single one, that a single path or a single flow or a single system that needs to do ETL, but many of them. So from this, we can sort of like infer that it might be useful to make a more generally applicable facility that can be reused for all these cases rather than reinvent something new for each of them. And so we came up with this idea for Cloudera Morphlines, which basically embodies this concept that we have this reusable ETL system that we can embed and plug into various systems, such as Flume near real-time indexing, or for HBase indexing, or for MapReduce-based indexing, or for transferring, say, relational data into Hadoop and back using transformations in the middle, and so forth and so forth. So really, this is like a generalization of what we needed for search. And so the idea is that you can plug it into other applications as well, and whatever you have, and take it beyond the search use case. One of the requirements, if you do that, is that whatever that library does, it needs to be able to deal with a multitude of different input formats and a multitude of different data types. It can't just be confined to, say, like SQL data, or say, like XML data, or data format X, Y, or Z. It needs to sort of like be able to process, a variety of heterogeneous data formats and make sense out of whatever data is being thrown at it. So Cloudera Morphlines then is an open source framework that we recently made available under an Apache license, and it does simple ETL. Not necessarily, anything that can do, what like, real production, enterprise ETL tools like Informatica or SyncSort or Pentaho or so do. It's not a competition, for commercial enterprise tools. It's just a library really at this stage, but it's incredibly useful for our purposes, and I believe it's also useful in other contexts. And so it is designed to not just for batch applications, but also for near real-time applications for these different contexts. And we are making it available in the form of packaged up in the form as a library inside of the Cloudera development kit, which is a recent effort that we started about like half a year ago. And so as part of that, you can get Morphlines outside of the context of search. You can also get Morphlines obviously prepackaged, when you get Cloudera Search, but that's a different topic. And the idea is, yes, please.
Other Debian packages for it?
What was that?
Debian package management. Does anyone have Debian packages for it?
As part of Cloudera Search, we package things up, for a variety of different operating systems, including Debian and SUSE and Red Hat and CentOS and but as part of the CDK, we really just produce Maven modules. So, as far as the CDK is concerned, it's just Maven modules. But as part of Cloudera Search, we package it up, in a more like consumable way. It would work on any distribution of Hadoop. What was that? Does it work with any distribution of Hadoop? Yes, it does work with any Hadoop, distribution of Hadoop. Indeed, it doesn't actually have any dependency on Hadoop itself. So you could use it in your email application, or if that makes sense. Yeah. Mm-hmm. From a conceptual perspective, it reuses some tried and true, ideas, most notably the ones coming from Unix pipelines. The idea that you have like little programs or little plugins or little things that you plug together, and that do some transformation on a data stream, and then hand that data stream to the next plugin, which does something with it, and hands it off to the next plugin and does something with it. And so we took that notion a little bit further and made it more convenient for the purpose of like ETL flows, and we also made it more efficient. And it comes packaged already with a variety of plugins that do useful things out of the box, and then you can add, additional plugins that do, things that aren't provided or that you want to do differently. And so, for example, there's support for log files, and Hadoop, one of the extremely common use cases is to just dump whatever log files come available out of high volume, websites and production applications, and just dump it all into HDFS in raw form, which is kind of like log files, and then you can derive useful information from it later. And so, but by and large, you have like humongous amounts of log files in pretty much unprocessed form, and so that's an extremely common use case, dealing with log files in various degrees of structured or unstructured manner. Then there's also support for Avro, which is a hierarchical data format, very similar to Thrift or protobufs. Something that is very often used in Hadoop ecosystem, and then also for legacy reasons, for sequence files, which is kind of like the precursor of the Avro data format. And then there's also support for data formats that aren't used as widely in the Hadoop ecosystem, like JSON and XML and HTML and things like that. And the idea is that we can never, and we do not want to provide some exhaustive functionality, but the system is designed so you can easily plug in whatever else makes sense for you and whatever else you need. So that's probably in the long run even more important than providing these things out of the box. It's nice to have things out of the box to have some critical threshold for doing something useful. But in the long run, what's actually more important is that people can plug in whatever they want and integrate their own stuff. Is much more important in the long run, I believe. And so it would make that easy. So here's a simple example. You have a syslog file with syslog records coming into the system. In this case, it's a Flume agent, sort of like a large-scale streaming ingestion system, and that agent runs what is called a Solar Sync, some kind of plugin that executes a Morphline, and a Morphline really is just a set of commands, a set of processing elements, a set of like you'd say filters, if you like, and so it runs whatever input in the form of events or records through a set of commands, which transform the record on the way, or can also generate multiple output records for each input record. In this case, it first reads one line out of the file, and then out of that syslog log line plucks out a bunch of substrings, the time and the process ID and the log message itself and who produced it and things like that, and puts it into record fields. So then the information is a little bit more structured than it was at the beginning, where it was just like a string, effectively. And then there's another command that it runs it through, which then loads the data into Solar. And if you strike out load Solar there, you could say maybe you want to load it up into HBase, or maybe you want to dump it into an HDFS file, or maybe you want to load it up into some online dashboard, or what have you. So that's the overall idea. And so the Morphlines part is like this set of commands that are tied together and run over input data. And whether that input data is a binary file or whether that input data is already a structured record, it will work for all of these use cases. And the idea then is we can take these components, these commands, and use them in multiple contexts. So you can use them in different ETL applications, and you can reuse these components so that you don't have to, reinvent the wheel every time. I already mentioned, it's heavily leaning on the Unix pipeline metaphor, and we decidedly did not want to build a system that can stand on its own feet, that is like a standalone server or something like this, but rather we built a library that can be embedded into other stuff, and we want to, because we know that we ourselves, we want to embed it into a lot of different systems. So it did not make sense for us to actually, build one server that is very specific for some purpose, but rather we want to embed it into multiple systems. And so what comes to mind is like not just Flume and MapReduce, we have already done that part, but also Pig and Hive and Scoop. So Pig and Hive are tools, high-level tools that let you allow you to express SQL queries or something that closely resembles a SQL and run it over data that's stored in HDFS and run batch jobs with something that closely resembles what a lot of people are already used to, SQL. Scoop is a tool to import and export data at scale from and to relational databases or enterprise data warehouses and connects Hadoop to these legacy systems and so forth.
So, does it support BZIP?
Does it support DBZIP at the time? It probably does, but I'd have to go and check. It basically picks up, whatever comes with the Apache Commons compress library, and I believe that also includes BZIP support, and so.
For instance, like if you're doing something like piping a lot of data that is in BZIP format or whatever to pigs through using pig to some scripting process, would that be a pretty, like if say if you were wanting to move to Java, is this pretty like straightforward?
Yeah, that would be. So there's a command called decompress that does that, and so it will look at what the file format is, and whether it's a gzip file or whether it's a bzip file. And I have to go back whether bzip is decidedly supported or whether that still needs to be added, and some compression format, and it will just basically unwrap that compression format and then spit out the decompressed stream of data. So so decompress would be one command in the pipe there, and takes as input like a compressed stream. And
well, today actually with pig, it's like seamless. Like it basically unbzips it. So maybe it's already in there in the, like you said, the Apache Commons.
yeah, it's probably already part of that package, but what you still would need to do is, we have facilities for this, is to detect what kind of file type it is. Is it a bzip file, or is it a gzip file, or is it a whatnot file? And we have a command for that specifically geared towards use cases like this called detect MIME type. And it does, a similar thing that web browsers do too when they get, arbitrary stuff over HTTP. It sniffs the first couple of bytes, or it looks at file names and metadata, data headers, and from that it can determine what's the file type. And then depending on that file type, it can fill in that information into a header, and then the next command, down the chain can look at that information and then say like, okay, I'm gonna decompress it with bzip, or I'm gonna decompress it with gzip, or I'm just gonna let it through unchanged or whatever. So it's got this notion of MIME types and how to detect MIME types, and then how to act on those MIME types depending on what it is. And it also has this notion of recursively unnesting container formats, such as compression formats, where you start out with like, it's an Avro file that contains records which are gzipped, and that, and in that side is that gzip, there's other records with some other format, and da 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 da. So you can unwrap that, that whole nested chain of things to get at the actual information that's deep down there, extract that out, and fill it into your record and load it up into whatever your target system is. I already mentioned this, it should be easy to plug in things. There's a class called command. It's got 3 methods that you need to implement if you want to implement a new command, and there's an abstract class that makes it even easier. Reduces it like to 1 method. So it's like a couple of lines of Java code if you want to write your own command and plug it in. And you don't need to register anything or provide some metadata. You just put it on the Java class path, and then it becomes available to the Morphline. The data model is very, very flexible. It's originally really taken from the search domain. It's really that we're dealing with records, and each record has a bunch of fields. A field has a name. It's like a hash table has keys. And then the field also has a list of values. In this case, they can be arbitrary Java objects. So it's really just basically a hash table, with string keys and with an array or a list of Java objects as values. And that's the data model that we operate on. It's directly corresponds one-to-one to the Lucene and Solar data model. It also corresponds to, any other search server out there uses precisely the same data model, whether it's Google or Bing or whatever. And the relational data model is very close to that either. Usually, people think of a relational table as like, it's just got one value in a column, but like really actual systems, allow you to have multi-valued, entries in a column as well. And so it's really a tried and true generic data model that fits, the bill for all sorts of use cases, not just search. And when you add in the fact that the values aren't just strings or integers, but they can be Java objects, meaning like, say, like a Java input stream, or a byte array, or a JSON tree or whatnot, then you have a fairly flexible generic facility that allows you to manipulate all sorts of data without having a preconception of what it is that the application wants to do. How do we pass in binary data? There is, as I mentioned, a way to deal with input streams and byte arrays. And so by convention, we have a field called attachment body, similar to, say, like an HTTP message or like an email message. We have a field called body, attachment body, and you can fill in Java input stream in there that basically represents a file that you're reading, or maybe it's a byte array, represents an event from Flume, for example. And then you can also pass additional optional fields that are by convention named such and such, like MIME type, or character encoding, or a name for that object, that are useful to certain applications in detecting, what kind of data it is and how to interpret the data in case there's ambiguity. So then the idea is that we can deal with an arbitrarily large stream, really continuous streams of data, not just like the records contained in a table and then we're done, but rather continuous streams of data. And each command transforms its input record, receives an input record, into 0 or more output records. If you want to, like a router, ignore the piece of information because it's not applicable, you just drop it, you don't return an output record. Or maybe you want to transform it, you return 1 output record. Or maybe, say like an email might actually lead to multiple output records. Or say like a table or a file, a CSV file might actually lead to a gazillion of output records for one input record, every line being one output record. Or maybe you want to split a record field into multiple disparate fields and emit a record for each of those. So it's got this 0 to n output record capacity. And in simple examples, you have this linear chain of like a Unix pipeline where something pipes into something else and which pipes into something else. But really, commands can actually have some nested structure, like and embed other commands, which can embed other commands. So for more advanced use cases, that usually doesn't come up initially, but for more advanced use cases, you can really have like this flow that's through a tree of commands. So it's not unlike a data flow engine where you push information through a tree of transformation elements. So like the inverse of an execution plan in the query engine. And so because the system is explicitly designed to be embedded into other host systems, it makes no assumptions about and has no notion about persistence or durability or distributed computing. We're interested in expressing the actual transformations that people want to do and apply them in multiple contexts. And so basically, it's really just a chain of main memory transformations without notions about things that host systems already provide. Say like failover, persistence, distributed, like queues and things like that. All of that stuff is already provided by, say, like Flume or by Storm, or by Kafka or by MapReduce. And so there's really no point in reinventing these things, but rather, you embed this library into these systems that have their own way of dealing with high availability and reliability and so forth. We do, however, provide facilities to select past transactional contexts through commands, through that chain of commands. So like when a transaction starts, begins, and when it commits, when you roll back a transaction. So there are facilities to pass transactional concepts, transactional state through, which allows you to say like do efficient batching in reliable ways. So that load Solar command that I showed early on, it consumes one record and then it loads the record up into Solar, but it doesn't do it like one record at a time. It batches it up in larger batches and then sends a big batch into Solar to be efficient. And if you want to do that in a transactional context, these things, come in very handy to do that sort of thing reliably. In terms of performance and scaling, so a Morphline really is just a configuration file. It's not something that it's not Java code that you write typically, even though you might want to provide your own plugin. But really, it's just a configuration file. It gets compiled by the library on startup. You give it that configuration file, and it does something with it, and then it gets executed at runtime many times in some very efficient way. Why is it efficient? Because piping from one command to the other does not involve handing off, a piece of information from one thread to another thread, say like via a queue, but rather it's just a method call. It's a Java method call from one object to another object, and has minimal effort. The overhead of a Java method call. So there's no serialization involved and deserialization between commands in a pipe, and there's no context switches, and thread scheduling involved. So it's just, so that's something that's very important, for high volume, big data processing. And the other notion is there that a Morphline is single-threaded. It's running all the commands in the very same thread, And so if you want to have scalability in the number of, in the number of CPUs or in the number of nodes that you have in your system, you just run many of those things. You run many Morphlines, many clones of the same Morphline, one per CPU core, and on many machines. So like, you run 10,000, mapper tasks in your MapReduce job, or maybe you run like 100 Flume agents, and each Flume agent is running 16 Morphlines or something like this, and they all do the same. They all do it with the very same job facility, but they don't need to synchronize with each other. They're completely independent. In terms of syntax, we just adopted something that was already out there. It's called Hokon. It's basically JSON, slightly adjusted to the configuration file use case. So like in JSON, you can't write comments. It doesn't have no notion of comments. So they added in, the facility to write comments in there. So like so you can document your configuration file and make it, and some small little tweaks, that makes it a little bit more amenable to specify your configuration file. So we just picked it up, and it comes out of typesafe.com. And it's a little odd at first, maybe to look at, but people get used to it, at least in our experience, pretty quickly. So here's an example. So if you had a log file and it has stack traces in it, then typically that's a little gnarly. That's where like a lot of systems, like they don't really work so well, because a record really spans multiple lines, and you can't just say like, okay, we'll take it line by line. But rather, a record spans multiple lines. So how would you like take a log file and process that into records and then load it up into, say, like a search server or into HBase or into some other database? Well, Morphlines has one handy command for this. It's called read multiline, and it basically allows you to specify a regular expression for where the record starts and where it stops, and everything in between, constitutes a record. So that's one way, how you can, within a couple of lines of a configuration file, can specify, okay, how to parse that file format, and then how to load it up, say, into some target system. You also see there's this little command called log debug, that for debugging purposes, you can print out whatever the current record state is, what the content of the fields are in the current record. So you can print that out to a logging facility, to SLF4J, whenever you want. Here's some other example command. As I mentioned before, you can write your own plugins, you can write your own commands in Java code, and then make them available, and it's going to take you like, whatever, 20 lines of Java code or something like this. But oftentimes you just want to like, invoke some external system or a substring function or whatever that's not available as part of the standard commands, some small little thing that can be done like in a one-liner or in a three-liner, and actually writing a whole command and compiling it and putting it in a class path is already way too much overhead for a lot of people for doing that little thing. So now we have this, so we introduced this little command called Java, and you can write scripting code. It's actually full-blown Java code, but so like you can write that Java, code right directly inline there, and when the Morphline gets compiled, that thing gets compiled into a Java class and into Java bytecode and executed. So you can write some quick and dirty stuff or try things out that way pretty conveniently. I would not recommend like writing a 500-line Java transformation in this way, so like there's some abuse threshold somewhere. So I would say like, if it's more than 5 lines of Java code, it's probably better to write your own command, and unit test it and so forth. But if it's like 3 lines of code, then this is an effective way of getting the job done, I suppose. Huh? It's compiled. It's compiled into on startup when that configuration file gets loaded up. It just literally writes, a big string that contains like you usually would write in a Java program, and then it compiles that thing in memory, using Java compiler into a class and loads that class at runtime and then runs it, and so it gets cheated by by the Java runtime the way any other class gets cheated. So, and of course that happens only the compilation happens only once on startup of the program, and then you can run that command a gazillion of times, and it's calling this command then is just a one Java method invocation. It has that overhead, which is for practical purposes, like faster than you actually need it. Yeah. Here's a bunch of other commands that are currently already implemented and shipping. Say, we have, I mentioned this integration with Solr and log file analysis, single records, multi-records, CSV files, regular-based regular expression-based pattern matching and extraction, and a lot of things. I already mentioned like Avro and Excel and so forth. We also integrate with the Apache Tika parser library. Apache Tika is a library of hundreds of parsers for things that you don't want to write. Nobody wants to write, like Microsoft Word parsing, PDF parsing, whatever, JPEG, extracting the metadata from JPEG files about, how many pixels does that photo have, and, Lord knows what, stuff that you don't want to write, and so we just integrate with that library, and so there's like hundreds of, file formats that we kind of get for free, Plus, then there's this, also from Apache Tika, we inherit this nifty facility for detecting, by looking at the first couple of bytes of some content, what is actually the type, what's the file type, what's the content type of that byte stream, and then you can react in your commands. You can react to that. You can say like, if it's an application / PDF, then do da da da, and if it's a CSV, then do blah blah blah, and so forth. So there's a little if command, and things like that. So you can react to whatever the data format is and treat it in appropriate ways. I mentioned that scripting support with the Java language. You can add things to a field and set fields, and have assignments and comparisons, and it's sort of like the basic elements, of like some transformation, configuration language. If then else, there's a facility that people use a lot called Try Rules. It's a little rule engine, and basically the way that's being used for systems that need to cope with multiple different data formats. Say like a log file where records aren't actually just in one format, but for whatever reason they come in like 5 different formats. They're all slightly different. They're kind of like the same, but then they're also different. And so you need to parse them properly and deal with them in some, coherent way. And this try rules command allows you to do that, to try different matchings, and then if things match, then do this, and if it doesn't match, then try the other thing and match that, and if it doesn't match, then try something else, and so forth. It also integrates with the metrics library from Yammer. So every command, it's in production, like if you have these systems running, and they run 24/7, it's important to get some insight into like where the time is spent and how many errors do you have, and what's this thing actually doing in production, and get some operational visibility into how the system actually does, and so every command can access, these metrics library, so you get timers and counters and and meters and histograms and whatnot, and so all of that can get published, to Gangly or whatever monitoring system you have, or to JMax and things like this. So inherit this. And then it's got this, unpacking or unnesting of like nested data formats that I already hinted at. I also hinted at already the plugin infrastructure. There's 2 classes, that to implement. It's very easy. You don't even need to provide like some configuration file that describes, like, what the names of these commands are or something like this. You just put it in a class path and that's it. So here's an example that uses a command called Grok that a lot of people use for log file processing, and we adopted that from the Logstash project, which has a very similar facility. And so it basically allows you to specify regular expressions in a little bit more scalable way than usual, by saying that we can define a library of regular expressions in a file, or even inline here, and give each regular expression a name, and then we can compose regular expressions by like stringing together these names, rather than like these humongous expressions, and humongous and another humongous expression, so that you can build up complicated regular expressions that are still tractable. And here's one that parses a syslog file. First, it's being run through the readline command, which basically spits out a record with one line at a time. And then it's run through that Grok command, and it looks into that dictionary, which is like a configuration file that you can provide. And then it says, match the field called message, try and match it against that expression, this Grok expression, that basically plucks out various substrings, say like the process ID or the timestamp and things like that. And so you don't actually write your regular expression literally in there, but you just refer to, say, like a timestamp name. And under the covers, the timestamp is actually a real expression. But once you've defined that, and it is actually already defined for you, then you don't actually need to invent that regular expression and unit test it and so forth. And so we have this long library of regular expressions that we adopted from the Logstash project. It's got hundreds of regular expressions for common things like timestamps and host names and emails and whatnot. So you can just use them, and you don't actually have to debug them or write them yourself, and you just refer to them by name. Of course, you can extend it with your own, dictionary files, if that's what you do. But this comes in really handy. I would say this is by far the most commonly used command in our experience, at least, for Cloudera Search. There's other things that you could do that we have not done, but like that, would be very interesting to do and quite conceivable, which is like to, join, records as they flow through the system with external data sources, so you like, lookup tables or relational databases or HBase, or annotated, records, with, say like, do GeoIP lookups, or pluck out, other kinds of information, do DNS lookups, or maintain streaming analytics over time windows, over sliding windows, on the records that flow through the system, things like that. So things that remind us that if you look at it, it's kind of like a stream processing system. It's a stream processing system without, the server. It's just the embedded piece of it, if you like. So you could plug this into Storm. It's not a replacement for Storm, but you could write, a Storm plugin that runs a Morphline, and as part of that, does stream processing in this similar way that we provide a plugin for Flume that runs a Morphline as part of Flume, things like that. So I'm going to talk a little bit about like how we use these things in Cloudera Search to illustrate a little bit about the applicability of Morphlines in that context. So Cloudera Search is basically something that fits into the Hadoop ecosystem since we integrated Solr with CDH and with Hadoop. And so it's basically the idea that you have this giant storage system, HDFS, and you already have all of your data in there, and increasingly more and more applications are running on it. And you also want to do search on it, but you don't want to do it in some yet another silo, but on the very same storage system that you already have, and so it's integrated, with like the same management infrastructure, same failover and availability of, that HDFS has, and so forth and so forth and so forth. But at the core of it, really, it's like an integration of CDH with Apache Solr. And I already showed that picture, but we're going to dive a little bit more in detail in how Morphlines are being used here. Just a reminder, we have Flume Flows, real-time ingestion flows going into search servers. We have HBase, interrupted and deletes, CRUD, transactions happening in, and we maintain secondary indexes on that data in Solr so that you can search over your HBase data. We also have MapReduce facilities for running MapReduce jobs that index giant heaps of information offline and then load them up into Solr. And each of those demands ETL and we do that using Morphlines. Now for Flume, the way Flume works is that very often people use it to ingest log files. You can use it for other stuff too, for any kind of binary data, but most often people use it for log files. And so Flume is really a graph of processing elements, distributed processing elements that ship data from some source system into a destination system. Most commonly that's HDFS, but can also be Solr or any other system. And we provide an integration point called the Morphline Solr Sync, which is the Flume has this notion of syncs, which are kind of like it's a plug-in mechanism for Flume to take some data along that flow and then do something with it and load it up into some system. There's, for example, an HDFS sync. So if data comes in, it dumps it into HDFS files, and that's the most common use for it. But now we also have a Solr sync, a Morphline Solr sync, and it dumps the data into Solr, except for dumping a raw data into Solr isn't very useful. So we run a Morphline over it, and then we'll run that Morphline, and the last command is load Solr. But if you strike out that last command, you could load it up into HBase, or you could load it up into whatever. And so we have that integration with Flume. And that has been upstreamed, and it's shipping as part of Apache Flume 1.4. Inside of Cloudera Manager, this is this proprietary enterprise management tool that Cloudera ships, and that provides a lot of its revenue. We have like GUI tools, for configuring and managing and monitoring all of that stuff. So that's not part of, like the open source offering. All the management tools are like proprietary, but the functioning system is all open source. So for how does it work for batch with MapReduce? So the overall idea is you have these HDFS files. You have a tool that selects whatever files are interesting to be indexed or to be loaded into the ETL tool, and then we run it through a Morphline as part of the mapper and produce some output index shards, and those shards are then loaded up into Solr using a final go live step. And the way we package this up is using the so-called MapReduce indexer tool. It takes a configuration file, this Morphline configuration file, just a text file, and it runs it on every task of every mapper on that cluster, and extracts, and transforms and does whatever it has to do. And then the output of that goes into reducers, which then combine the information and so, like, for example, eliminate duplicates of the very same piece of information, and then build Solr indexes, which are then loaded up into Solr. And again, if you strike out that load Solr piece of it, you have a MapReduce, ETL processing system that just, as part of your mappers, runs a Morphline and does whatever he wants to do. So you can use it for other things as well. How does it work for HBase? Well, we use Morphlines for near real-time indexing. HBase has a facility to allow for replication of an HBase cluster to a slave cluster for, backup or for high availability, and things like that. And the way we work this is that we plug ourselves into the replication mechanism and essentially listen in on the transactional log. We get every transaction that happens in HBase, and we listen in on that log because we are a fake replication target. We're a fake replication slave. We pretend to be like a HBase cluster, but we're not. We're an indexer, really, you know. But we receive all the updates, and then, you know, run every record or every cell through a Morphline, and the output of it goes into Solar. So that's the way we build secondary indexes on HBase in a way that does not impact the production readiness of existing applications that are already very much rely on the HBase and do want to make sure that any kind of instability or performance issue with Solar does not impact their reads and writes into HBase. By hooking ourselves into this slave mechanism, basically we get eventual consistency. We don't get like immediate consistency, but on the other hand, you know, like even if Solar goes down or if there's some issue, it's not going to impact the HBase primary cluster and the applications and the latency of these applications. And so we did that work in conjunction with a company called ngData. And so the result of it is this Lily HBase indexer that runs a Morphline to do ETL and feed search indexes. And so when you put all this stuff together that I mentioned, you get a little bit more of a messy picture with all these elements in there, you know, where HBase and Flume plays a role, and Solar plays a role, and HDFS, and so forth and so forth. And the idea is not to confuse you or with like that messy picture, but it's sort of like to drive home the point that there's an awful lot of paths in that system where you need to do an ETL. And that was the main point that we try to address with Morphlines, which is that we need this thing in all sorts of different places, so we better make it embeddable and reusable so that we don't have to do this any number of times, you know? Yeah. So what are we going to do next? The HBase piece isn't actually completely finished yet. No more work to be done there. And then Morphlines will also be integrated into Apache Crunch, which is another Hadoop processing framework, high-level processing framework. And we're also thinking about writing commands for stream analytics that allow you to, you know, what previously was not possible in Hadoop, which is to do sub-second, you know, sub-second latency stream analysis and, you know, interactive dashboardings and things like that. So, in conclusion, to wrap it up, that all of that stuff is shipping as part of the Cloudera development kit for developers. You can pick it up there or contribute there, and there's a mailing list, you know, for people to interact, you know, if you're interested. And there's also a prepackaged version of it that ships with Cloudera Search for those kind of applications. If you want to try it out, maybe the easiest way is to download the Quickstart VM, the CDH Cloudera CDH Quickstart VM, which contains the whole enchilada, but among them also Morphlines. So it's an easy way for you to set up a system and try out, say, like MapReduce indexing with Morphlines or Flume indexing with Morphlines and things like that. Huh?